Hello everyone, in this video we're going to learn how to evaluate inverse trig functions. Now before we do that, we actually need to know restrictions really well for each inverse functions that we have. Now let's have a look at the first one, y equal to sine inverse of x. We can rearrange it so it will become x equals to sine y. We know that y is the angle, and in order to make the sine function to be invertible, we actually had a restriction for its angle. So the angle restriction is between pi on 2 and negative pi on 2. Now what that means is, if we put it on the quadrant, we actually refers to the first quadrant and the fourth quadrant. So the angle has to be in these two regions. Now let's have a look at y equals to cosine inverse. So we can do the same thing, x equals to cosine y. And the angle restriction for the cosine function is between 0 and pi. If we put it on the quadrant, that actually refers to the first quadrant and the second quadrant, so that means the angle has to be in these two regions. The last one, we have x equals to tangent y when we rearrange it. And the angle restriction is between pi on 2 and negative pi on 2. So this means it's the first quadrant and the fourth quadrant in these two regions. But please note, the angle restriction for tangent function does not include pi on 2 and negative pi on 2. Now let's have a look at question 1. Evaluate the exact values of the following. The first one is y equals sine inverse of the root 2 on 2. Now, probably based on your exact values knowledge, you can straight say, oh, this must be pi on 4. Now, what I'm going to do is I'm going to consider the domain restriction for the sine function. So I can rearrange it, so it's sine y will give us root 2 on 2. Now, the angle must be between negative pi on 2 and pi on 2, so that means it has to be in first quadrant and the fourth quadrant. And the only quadrant angle will give sine positive value will be the first quadrant, so therefore I can say y is pi on 4. Now let's have a look at the second one. Y equals cos inverse of half. So I can rearrange it, so cos y equals to half. So the cos itself is a positive values. And we know based on the domain restriction, it's in the first, between 0 and pi, in the first and second quadrant. And only in the first quadrant, the cosine will be positive. So therefore, I can say y is pi on 3, because I know the cos pi on 3 will give us half. Now, the next one is y equal to arctangent of root 3. And remember, arctangent is actually same as tangent inverse. So I can say tangent y is root 3. Now we all know that y, if y equal to pi on 3, that will give me root 3, but we're going to just check with the restriction. For the tangent function, we restrict the domain into first and fourth quadrant, and because the tangent is positive value, so it has to be the first quadrant, so therefore y equals to pi on 3. Now what I would love you to do is pause the video here and try these questions by yourself, and then come back to check your answers. So let's have a look at the first one. Question D. Y inverse of negative root 2 on 2. So sine y equals to negative root 2 on 2. So based on the restriction, sine angle must be in the first and the fourth quadrant. But because the whole sine value is negative, therefore I pick fourth quadrant. So I know that sine pi on 4 will give me root 2 on 2. So therefore in the fourth quadrant, y should be negative pi on 4. Question E. Cosine y is negative root 3 on 2. Now for cosine function, the restriction is between 0 and pi, so in the first and second quadrant. And because the whole cosine value is negative, so therefore we choose the second quadrant, because in the first quadrant everything is positive, in the second quadrant only sine is positive and the cosine is negative. So we know that cosine pi on 6 will give us root 3 on 2, so therefore we know y must be pi minus pi on 6, so therefore 5 pi on 6 is the answer. Question F. Y equals arc sine 0. So that is same as sine inverse of 0, so sine y is 0. We all know that sine 0 will give us 0, but we just double check with the restriction. For the sine function restriction is between negative pi on 2 and pi on 2. So therefore, y equal to 0 radian will be the correct answer. Now let's have a look at the cases of combining trig functions and inverse functions. Now, one key thing that you need to remember, the method that we're using for combination of the trig function and inverse trig functions are working inside out and also know your restrictions really well. Now we're gonna actually have a look at a lot of different types of questions here, and I'd love you to actually pause the video to try it yourself to figure out and then come back to check your answer. Let's consider sine of sine inverse of x. Now sine of something, this one is actually can be seen as the angle, so therefore we can say sine inverse of x is theta. Rearrange it, we know sine theta is x. What we are going to do here is to think about the restriction. So for sine inverse of x equal to theta and rearrange sine theta equal to x, in order for sine theta equal to x has an inverse, there's a domain restriction. And the domain restriction for this is the angle is between pi on 2 and negative pi on 2. Therefore, the range for this case is x is between 1 and negative 1. So we clearly know this x has to be between negative 1 and 1. Now we're gonna actually draw a right angle triangle to help us to visualize it. So this is angle theta. Sine theta equals to x. We can see this one as x over 1. So therefore its opposite is x, hypotenuse is 1. Now we have sine of theta. This can be written as sine. Replace the theta with sine inverse. And we know that sine theta is just opposite over hypotenuse, so that's equals to x. So just by doing this, we realize that sine of sine inverse of x equals to x. However, the restriction is x must be between 1 and negative 1. Now let's have a look at the second one, the cosine inverse of x. Now we can have a similar approach. We can say this cosine inverse of x is angle theta. So we rearrange it, so cosine theta equals to x. Now again, there's a restriction here. The theta must be between pi and 0. And from here we know that x must be between 1 and negative 1. Now based on this, we're gonna actually draw the right angle triangle. So the cosine theta is the adjacent over hypotenuse, so x over 1. Now what we're going to do is we're going to do the same thing. So the cosine theta, which can be replaced by the cosine inverse, so that should be equal to x over 1, which is x. Now again, there's a restriction for x, which must be between negative 1 and 1. Now for tangent of tangent inverse, we have the same approach. So we say this is the angle theta. So tangent inverse of x is theta. Therefore, tangent theta is x. We know the angle restriction is between pi on 2 and negative pi on 2. And x can be any real numbers. So from here, tangent theta, again, we can use a triangle, right angle triangle here. So tangent theta is x, so that means the opposite is x and the adjacent is 1. And now we can rewrite this as tangent theta as tangent inverse of x, and we know that that is same, which is x over 1, which is x, and x can be any real numbers. Now let's have a look at the first question here. Sine of arcsine half. Now this is actually same as sine of sine inverse of half. Now we're just gonna look at this half here, which is x that's mentioned in the previous slide. there's a restriction. You just need to see, is this actually within the restriction? So that x has to be between 1 and -1. And we can confirm that the this half is between -1 and 1. So therefore, the answer is half. Let's have a look at the second one. We have cos of arc cos. So again, arc cos means cos inverse of -0.3. Let's check -0.3. Is this between -1 and 1? The answer is yes, it is between -1 and 1. Therefore, the answer is -0.3. Let's have a look at the next one, question C, tangent of tangent inverse of -2.5. What's the limit for this x value here? X can be any real numbers, so therefore we say that the answer is -2.5. Now let's have a look at the last one. We have the sine of sine inverse of -3.7. -3.7 is actually outside of -1 and 1 restriction. Now you can actually think in this way. We're gonna let sine inverse of -3.7 be theta, and we rearrange it. That means sine theta is -3.7, which doesn't make sense. We all know that sine function for y equals sine theta, the maximum is 1 and the minimum is -1. So it's definitely out of the boundary. So therefore, we say there's no solution, and we can say this is undefined. Now let's consider another way. Now the outside function is the inverse, or here it says arc sine, arc cos, arc tangent. In fact, they're actually exactly the same as sine inverse, cosine inverse, and tangent inverse. Now, sine, so I'm going to write it down here. Sine, arc sine is same as sine inverse of the sine x. And you know this x is the angle. And the angle restriction is between -pi/2 and pi/2. We are going to let the whole sine inverse be theta. What that means is, if I rearrange it, that will give me sine theta equals to sine x. Therefore, we can say sine inverse of the sine x equals to theta. And the restriction for this x is, because it's the angle, it's between pi/2 and -pi/2. So we can do the same thing for the next one. We can see this as cosine inverse of cos of x. And this will give us x. And we know that x must be the angle, so the angle restriction is between pi and 0. Now, if we look at arctan of tan x, that is same as tan inverse of the tan of x. And that will give us x as well. And we know the restriction for the angle is between, without the equal sign, pi/2 and -pi/2. Now let's have a look at these examples, but what I would love you to do is try these questions on your own and come back to check the answers. Now let's have a look at the first one. Now my approach is going to be inside out. I'm going to start working whatever's inside the bracket first. So arc cos is same as cos inverse of cosine 2pi/3. Now if I put 2pi/3, it's roughly here, it's in the second quadrant. So in the second quadrant, cosine is negative. So therefore, the whole value is -half. And cosine inverse of -half, we're actually technically going backwards again. So that will give us 2pi/3 because the angle must be between 0 and pi. So only the second quadrant will give us a negative value. So you can straight away make a conclusion this whole thing is just equal to 2pi/3.